we've got another decomposition. So we've got one, and I want to list these out separately. So we only have two different types of atoms in here. I've got sulfur and I've got oxygen on the reactant side. And I'm going to list them in the same order on the product side. Sulfur and then oxygen. And here's the thing. Usually oxygen is kind of all right when you're going through this process, but sometimes it can be a real pain. I always balance the oxygen last, no matter what. Sometimes, as it turns out, when you balance the oxygen, you mess up everybody else, and then it just gets really confusing really fast. I think it's just easier to balance the oxygen last, and so therefore I always write it last. Right now it looks like I wrote it last just because I went from left to right, across my my reactant, but that's not necessarily why I did that. I do the oxygen last all the time because it can be a real pain. So right now I'm going to look at how many moles of each atom I have on the reactant side, and it looks like I've got 1 mole of sulfur and 3 moles of oxygen atoms, right? To make sulfur trioxide, that's what we have there. But if you look over on the product side, I have 1 mole of sulfur atoms, and I've got 4 moles of oxygen. So there's 2 in the sulfur dioxide, and then I've got molecular oxygen. So there's 4 moles of oxygen on the product side. So what am I going to do? Well, I start at the top. It looks like I don't have an issue with the sulfur, so I'm going to zero in on the only other atom that's actually in there, and it's the oxygen. So I need to find a way to balance out the 3 and the 4. What do you think the easiest possible thing would be to do? Now, sometimes you get lucky. Like we're lucky right now, and this may be, valid for us, or it may be not. But every once in a while, when you notice that your oxygen is odd on one side and even on the other, and obviously unbalanced, it's really nice to see that you've got molecular oxygen over there by itself, because sometimes you can use that to your advantage. I think the easiest thing to do in this case would be to actually find the lowest common denominator between 3 and 4 and then shoot for that. So I'm just going to call it and say, let's say 12, right? And then what do I need to do to turn a 3 into a 12? Probably need to multiply it by a 4, right? And you know what? It never hurts to just put down your first idea, and if it doesn't work, then it doesn't work. You just erase it and start over. But I'm going to put a 4 in front of my reactant, and what's going to end up happening is I'm going to change both the sulfur and the oxygen, right? So I'm trying to fix the oxygen, but when I put a 4 in front of that molecule, I change everybody in it. So you have to re-add up everybody. So I've got 1 mole of sulfur is to 1 mole of sulfur trioxide, and then I've got 4 moles of sulfur trioxide. So I've got 4 moles of sulfur. And I was trying to balance out the oxygen, right? And get 12. So I have 12 moles of oxygen. So now I have a new scenario here. I've got 4 moles of sulfur on the left, 1 mole of sulfur on the right, 12 moles of oxygen on the left, 4 moles of oxygen on the right. I'm not going to worry about the oxygen yet. I'm going back up to the top, even though I started out by trying to balance the oxygen. And that's how I ended up with, 4 moles of sulfur in the first place. I'm not going to continue with the oxygen. I'm going to start back at the top and say, I need to balance the sulfur. In order to do that, I need to put a 4 in front of the sulfur dioxide. So when I do that, I change everybody once again. So I get 4 moles of sulfur, right? If there are 4 moles of sulfur dioxide. And then what happens? Well, 4 times 2 for the oxygen, that's 8. But then 2 for the molecular oxygen. So 8 and 2 is 10. I still have not balanced the oxygen. But there is some good news. It's even on both sides now. And what's good about that is the left-hand side is bigger than the right, and I have a molecule on the right-hand side that only has oxygen in it. And that particular molecule has an even number of oxygens. So this is good news. So what would you think you'd have to do to increase the product side with oxygen by just 2 moles? It looks like I'm going to use the molecular oxygen, and I'm going to put a 2 in front of it. What ends up happening is I don't affect the sulfur. I affect only the oxygen because there is no sulfur in molecular oxygen. So now I have to add them up again. I have 4 times 2, which is 8, right? So that's one of my products. And then I've got 2 times 2, which is 4. So I have 12. So I've gone ahead and I have balanced the entire reaction equation just by systematically plucking my way through each of the atoms that are involved and the number of moles of each of the atoms involved. No one's gotten a charge on them, so we don't have to worry about that. For the most part, you don't. When we're dealing with redox reactions or acid-base reactions, occasionally you'll have to worry yourself with the charges, but for now, we're good. I'm going to get rid of our little pile of stuff there so that we can see the next problem a little bit easier. And so for the next problem, again, I'm going to make a big list under the reactants, and I'm going to make the same list underneath the products. And I'm going to start with boron. So we got boron, we have hydrogen, and we have oxygen. And then on the product side, I'm going to make the same list. Boron, hydrogen, and oxygen. And on the reactant side, I see that I have 5 moles of boron atoms. I have 9 moles of hydrogen atoms, and I have 2 moles of oxygen atoms. And on the product side, I have 2 moles of boron. I see I have 2 moles of hydrogen, and I've got 3 and 1. I've got 4 moles of oxygen atoms. So now I'm going to go back up to the top and I'm going to say, fine, I'm going to start balancing, and I start from the top and I work my way to the bottom. That's why I always keep oxygen at the bottom, just in case it causes trouble. So what I'm going to do is I have to figure out a way to balance the boron, and unfortunately there's an odd number on the reactant side and an even number on the product side. And that's okay. So what I'm going to do is, because I can't take away anything from the reactant side, I'm going to put a 5 in front of my product here, and that's so I can turn this 2 into a 10. When you have an odd and an even, sometimes it's nice to just find the lowest common denominator, and then what do you have to do to achieve it? Well, we're going to multiply the 2 by 5 to get a 10. Which means that we're going to end up having to multiply the other side, right, by 2. But we're going to get there in a sec. Let's finish off what we've destroyed over here. So 2 gets turned into a 10 when I put a 5 in front of that particular molecule. I've also affected the oxygen because boron's not the only thing in that molecule. So now I've got 5 times 3, and that's 15. And then there's 1 over there in the water. So I have 16 moles of oxygen atoms. And so now on the other side, I have to go again and I have to balance the boron. But this time, in order to make a 10 out of a 5, I need to put a 2 in front of this reactant. And so this 5 then becomes a 10, and I've affected the number of hydrogens. There are 18 now, 9 times 2. I did not affect the oxygen. Now we look at our situation and we're like, well, the boron is all balanced. That's great. The hydrogens are all messed up, and that's okay. So it's 18 on one side and it's 2 on the other. So it's both going to be even. So that's a treat. What can I do to make that 2 turn into an 18? Now I see that I have water, and water has 2 moles of hydrogen for every 1 mole of water. So what if I put a 9 in front of the water? Then I have 18 moles of hydrogen atoms, but I have also messed around with the oxygen because water also has oxygen in it. Now I have to add up all the oxygen again. I still have 15 from that 5 times 3 over there, the other product. And 15 plus now I have 9. So that's 24. 24 moles of oxygen atoms on the product side. I notice that now the boron and the hydrogen are balanced, but the oxygen is not. And as luck would have it, one of our reagents is just oxygen. It's molecular oxygen. It's an even number in the molecule, so that's great. So now all I have to do is turn that 2 into a 24. What would I have to do to turn the 2 into a 24? Well, probably multiply it by 12. So if I multiply, or put a 12 in front of molecular oxygen, I now have 24 moles of oxygen atoms on the reactant side, and I have 24 moles of oxygen atoms on the product side. So now everybody is balanced. Now you can do this by trial and error, but I think that sometimes when you're doing things by trial and error, it takes you sort of the better part of your life to figure it out. And this number combination, these ratios aren't super obvious. So that's why I like to make the little list underneath the reactant side and under the product side. And it helps to keep track of what's going on. So this next one, I'm going to make the same list. I'm looking at this thing and I think it's probably not going to be that big of a deal. It looks pretty obvious, but because on the reactant side I have split the nitrogens up, I think maybe it might behoove us to just write them out just to be on the safe side. I think I'm seeing that this is going to be a quick fix, like a real quick fix, but let's do this out anyway. So we've got nitrogen, hydrogen, and oxygen on both sides. This is where, like, if you are looking at a reaction equation and you see, nitrogen, hydrogen, oxygen on the left, and then all those are on the right, and then there's a sodium, you want to sit there and go, wait a second, that can't make sense, right? You can't create something out of nothing. So either you copy down the reaction equation wrong or, who knows what happened, but you can't just have like this mystery element appear out of nowhere. So when we're doing chemical reactions anyways. So on the left, on the reactant side, we're going to add up all the moles of everybody. I see I've got 2 moles of nitrogen atoms. I have 4 moles of hydrogen atoms, and I see that I have 2 moles of oxygen atoms. So we're going to decompose this thing as ammonium nitrite. We're going to decompose that to nitrogen gas and water. And on the product side, I've got 2 moles of nitrogen. I've got 2 moles of hydrogen, and I've got 1 mole of oxygen. So this does look like it's going to be a pretty easy fix, doesn't it? It seems like if I'm going to go down and the nitrogens are all set, those are balanced. But I have to double the hydrogens on the product side to balance those out. So I'm going to put a 2 in front of the water. And when I do that, I will magically balance also the oxygen. So I'm done. So sometimes these are a lot easier than they look, or sometimes they're as easy as they look. But I like to make the little list all the time just to be on the safe side.